Continuing on that lesson that we were just looking at, now I want to go over how would you use sine, cosine, and tangent to find a missing side in a right triangle. So, couple key things that we're going to do here. We're going to label our opposite, adjacent, and hypotenuse based on our reference angle. Then we're going to determine what side you know and what side you want to find. So, for example, maybe I know the adjacent and I want to find the hypotenuse. Then we'll use SOHCAHTOA to figure out if it's sine, cosine, or tangent. This is what we're going to do. I'm going to model this on the next problem. So let's see if we wanted to find the length of AB. So that is my side I'm trying to find. I know my reference angle is 30 degrees in this right triangle. I'm going to label my sides, opposite, adjacent, hypotenuse. Across from the reference angle is the opposite. So I want to find the opposite side. So remember that acronym SOHCAHTOA was going to help us know if it's sine, cosine, or tangent. So right away, I look and I see, SOHCAHTOA, opposite hypotenuse, adjacent hypotenuse, opposite adjacent. I want to find the opposite, so it's got to be sine or tangent, because those are the only ones talking about the opposite side, that O. All right, so is it sine or tangent now? Well, I know this side is the adjacent, so I have the adjacent side. So I have adjacent, I want to find opposite. So I'm going to use tangent, because that has O and A, opposite and adjacent. So tangent of my reference angle, I'm going to say theta, equals opposite divided by adjacent. That will help me remember what's on top and what's on bottom. The first letter is top. The second letter is the denominator. So opposite divided by adjacent. And remember, you have your notes. If you ever forget this, it is right here. SOHCAHTOA, opposite and hypotenuse, adjacent hypotenuse, opposite divided by adjacent. So we're using tangent on this one. Oops, let me go back. So I want to find AB. So I don't know the opposite side. So my opposite side is going to be my x. Tangent, my theta is 30 degrees. My angle, right? Theta is the angle. The opposite side is x. And my adjacent side is 6. So all I have to do now in my calculator, if it helps you, think about this side as a fraction as well. And we could just cross multiply. X times 1 is x. Tan 30 times 6, or 6 times tangent of 30. Now you're probably like, Mr. S, what is tan 30? Tan 30 is just a decimal. Remember, these are just decimals or ratios. So tan 30 is 0.5. So I'm going to do 0.5 times 6. 0.577 times 6. One thing, don't put it in the parentheses. So times 6. So that is half of 6, right? 0.7, so 3.4. So my missing side is 3.4. One thing that you want to notice here, 3.4. Remember, this angle is 30, this angle is 60. So the bigger side is across from the bigger angle. So this is the bigger side. The opposite's got to be smaller. So 3.4 makes sense. If this was a 45-degree angle, the sides would be equal. But we know it's going to be like 57%. So tan 30, if you want to think about a percent, the opposite side is like 57% of this side. That's all that's happening. So a couple things to remember. We want to make sure we label our sides, which one we're trying to find and which one we know, using our reference angle. Then we want to figure out, using SOHCAHTOA, am I going to use sine, cosine, or tangent? This one was tangent because we had the opposite side and we had the adjacent side for this problem. We wanted to find the opposite and we had the adjacent. Then you just got to set it up and cross multiply to solve for x.